We've just calculated that the electric field between R1 and R2 in this coaxial cable is given by this. So now we can calculate the potential difference between the two rings. So the potential difference, or the voltage, is given by minus the integral from an initial point to a final point of E dot dl. We're going to take as our path just going from the inner ring out to the outer ring. So that's in the r hat direction, the same direction as the electric field, and the dot product will therefore give me 1 times the magnitude of those guys. So we get minus, let's take the constants out the front, r1 over epsilon 0, and then we're going to get 1 over r, and then dr, the dot product, giving us cosine theta equals 1. The integral of 1 over r is a log. We're going to integrate between the initial point of the path and the final point, and so we end up with minus sigma r1 over epsilon log r2 over r1. Now we can determine the capacitance of this capacitor. The capacitance is defined as the amount of charge you can store per unit voltage. So what's the charge going to be? Well, it will be the charge density on the inner surface times 2 pi r1 times the length of the cable, and then we divide that by the voltage, or the magnitude of the voltage, which is sigma r1 log r2 over r1 divided by epsilon 0, so that goes upstairs, and we can cancel the sigmas and the r1s. And that's the capacitance of a coaxial cable.